To understand how networks are built, let's start with a simple comparison. Imagine two growing cities connected by a single, narrow road. At first, with only a few cars, traffic flows perfectly well. Connecting two network switches together with one cable works exactly like that empty road. But as an office or a school expands, hundreds of computers, servers, and printers suddenly need to talk to each other across that one path. Watch what happens as the volume increases. The data packets have nowhere to go, so they begin to back up. The line flashes red because files transfer slowly and information gets dropped. That one cable has become a bottleneck, and if it snaps, every device loses its connection. If someone accidentally unplugs that wire or a port wears out, the entire system goes dark. Relying on one link is simply too slow and fragile for a modern network. The most obvious way to fix a crowded road is to build more lanes. In a network, that means simply plugging in 3 or 4 extra cables between our two switches. But as this diagram shows, standard network switches aren't designed to handle several identical paths at once. Because the switches learn where to send information by watching traffic, multiple active paths confuse the system. The blue data dots miss their destination and travel endlessly in a circle, creating a switching loop. If a looping message is meant for everyone on the network, the switch duplicates it. Those duplicates loop and multiply again. Within seconds, this creates a storm of data that overwhelms the hardware and crashes the entire system. To prevent those crashes, networks have a built-in safety mechanism called Spanning Tree Protocol, or STP. Think of STP as a strict traffic cop. The STP traffic cop instantly drops roadblocks on the extra paths. Normal traffic resumes safely on the original line, but the 3 new cables we just installed sit idle. We added those extra cables to get more speed, but the network's own safety rules shut them down to protect the system. We need a way to bypass those roadblocks without causing a loop. That's where EtherChannel comes in. Watch the diagram. EtherChannel takes those 4 separate physical cables and logically wraps them together into one virtual connection. This unified bundle is called a port channel. Because they are wrapped together, the STP traffic cop no longer sees 4 separate dangerous roads. It scans the bundle, sees one massive safe highway, and gives it the green light to flow across all 4 lines at once. By creating this illusion, the network can finally use the total speed of every physical cable at the same time. This only works if all the cables in the bundle match perfectly. They need the same speed capacity and the same internal settings on both ends. By logically grouping these cables, EtherChannel satisfies the safety rules and makes the massive capacity we actually paid for available for use. A common misunderstanding is that bundling 4 1 gigabit cables together creates a magical 4 gigabit speed boost for a single file download. Instead of forcing one file into a giant pipe, EtherChannel assigns different conversations to different lanes, keeping them in order. The green stream is web browsing in lane 1. The purple is a server backup in lane 2. A voice call uses lane 3. To keep things organized, modern switches use a universal language called LACP. Think of it like a digital handshake, where both switches agree on exactly which cables are part of the team before they start moving traffic. EtherChannel increases the total capacity of the network by beautifully organizing many different conversations at once. We've solved the speed problem, but what about that single point of failure we saw earlier? Look at our 4-cable bundle. If someone unplugs a port or a wire suddenly breaks, the damage is isolated. The bundle instantly detects the dead link, ejects it, and smoothly shifts its data stream to join the flow in the remaining 3 lanes. The total speed might drop slightly, but the connection between the switches never fails. The network stays online. EtherChannel transforms fragile, individual wires into a resilient, high-capacity highway that keeps the digital